Hello, and thank you for joining. My name is Carrie Gardner. I'm the Product Marketing Manager for FDM here at Stratasys, and I've had the pleasure of working very closely with our materials team, assisting in bringing new materials to the market. But with so many materials, we understand it is sometimes difficult to determine which material to use. Today, we hope to solve some of that mystery, at least as far as our high-performance materials are concerned. For our agenda, I will give a quick introduction of our presenter, followed by a high-level review of our FDM systems and materials. We will then dive into the various high-performance materials in our offering, showcasing various real-world examples of their applications. Lastly, we will summarize the various features and properties of these high-performance materials, leaving you with an understanding of which material are a best fit for an application based on their properties. I encourage you to enter any questions you may have during this webinar in the Q&A box on the bottom right of your screen. We will have time at the end to review and answer anything that comes up during the session. But first, let's meet our expert. Today's session will be presented by Nathaniel Clausen. Nathaniel is a product manager for our materials and has been with Stratasys since 2017, focused on the Fortis 450 MC and F900 materials. Nathaniel has been working to grow the material ecosystems through the launch of new products such as Antero 800NA and Antero 840CN03. He also leads the development of our partnership program and validated materials product portfolio.
Thank you, Carrie. And now we'll begin the presentation on FDM technology and materials. Stratasys offers the broadest and best-in-class portfolio for additive technologies, including polyjet, stereolithography, industrial FDM, origin P3, and SAF. With this wide variety of different additive manufacturing technologies, Stratasys can provide solutions for all your additive needs. Focusing on Stratasys patented FDM technology, FDM is the process of laying down thermoplastic filaments layer by layer to build a functional part. It can build everything from concept models, functional prototypes, manufacturing tools, jigs, fixtures, and end-use parts for various applications. It is capable of using standard engineering grade and high-performance thermoplastics. And with the FDM technology, printers ranging from your desktop models all the way up through your heavy industrial F900 system. Looking beyond the printer, Stratasys offers a complete solution, including the hardware, software, and materials needed to produce the parts that customers need. Focusing on the materials themselves, Stratasys offers three tiers of options, including a preferred, validated, and open material model. For the preferred materials are the most advanced and complete materials that have been tuned to maximize both the performance of the material and surface finish of the parts, along with part accuracy and repeatability. For validated materials, these materials are produced to the same Stratasys standards with manufacturing of the filament and tuned to the same extent as a preferred material, but the amount of validation work and data that is provided on these materials is slightly less than that of a preferred material. With the open materials, this allows customers to utilize non-Stratasys products to either integrate and tune those materials for use on Stratasys printers, or to modify existing parameters for either preferred or validated materials to maximize performance for the specific application that they are looking at using it for. Within the Stratasys portfolio, we have a wide range of various product offerings, including thermoplastic elastomers with our TPU92A, standard polymers including ABS ASA and ABS ESD7, along with a variety of colors. As a validated material, we do also offer HIPS, which is a high-impact polystyrene. Within our engineering grade of polymers, we have a variety of different nylons, including nylon 12, nylon 6 in Duran, along with polycarbonate offerings and lightly filled ABS CF10 and nylon CF10. For flame retardant material, we do offer Kimia PCFR through our partnership with Kimia, along with a variety of colors for our PC and PC ABS options. In our high performance materials, which is where we'll be focusing on for this presentation, we have two Ultim resins that we offer, including the Ultim 1010 and Ultim 985. 2 different Antero formulations, the 800 NA, which is just a straight neat formulation, along with our Antero 840 CN03, which is an ESD formulation. We also offer a filled nylon in PPSU. We have a new material through our partnership with VICTREX, VICTREX AM200, which is a PEEK material that is now available on both the 450MC and F900, along with a variety of colors for our Ultim 9085, including some industry-specific colors, along with red as a tooling material. When talking about our high-performance materials, those are available on 2 of our platforms, the Fortis 450MC and the F900. Both of these printers are industrial capable printers, with the Fortis 450 being the smaller build size at 16 by 14 inches square and able to print up to 16 inches high, while the F900 is a much bigger build platform at 36 by 24 inches with a 36-inch vertical print capability. As far as material options go, both printers offer a wide variety of the entire material portfolio, with a couple of exceptions that are available on the F900, which include nylon 6 and the ST130 material. All other materials are available across both platforms. All right, moving into the specific high-performance materials and use case examples for our products. Starting with Ultim 985 resin from SABIC, this material is a high-performance PEI blended material that is commonly used in the aerospace, automotive, military industries. It is FST rated for flammability, so it is capable of being used in commercial aircraft. It has a very high strength to weight ratio, high heat deflection temperature, and we do offer 2 grades of this material. We offer our standard Ultim 985 resin, but we also offer a CG version, which does come with full traceability of the raw material and filament production for use in aerospace and other commercial applications. Typical applications for this product are aerospace interiors and various other production parts for a variety of industries. Looking at some use case examples for this product, Airbus is a strong user of the Ultim 985 material for various interior applications within their Airbus fleet of aircraft, including the A310, where they were able to produce a crew seat component. This was used for spare parts and replacement parts for damaged components within the aircraft. Airbus has produced more than 1,000 FDM components that filled missed part production needs for the initial A350 deliveries. They are currently flying tens of thousands of serial production parts across their fleet of aircraft, along with using a variety of spare parts and replacement parts made from FDM technology to keep their aircraft in the air and reducing replacement part costs. Here's a few examples of parts that are installed on the A350 by Airbus. These parts were produced by DO Aviation. One of the primary parts is this screen guide that sits between the various cabins within the passenger space of the aircraft. This is a common part that does get damaged and needs replacement. They're able to produce it using the Fortis F900 with the Ultim 985 material to come up with a much lower cost replacement part that they can produce quickly on demand to meet their service needs. Here's an additional example of a component made by the Italian Space Agency. This component is a housing for electronics fixture that is housed on the outside of a telescope. Being able to produce this custom component using the FDM technology in 985 significantly decreased their design timelines and was able to replace what was metal parts and aluminum parts with polymer parts, reducing weight on the finished components. This component is used to house various electronic sensors, switches, and other connectors. The reason that they were able to choose the Ultim 985 is due to its FST rating, the fact that it has very, very low outgassing and would not impact other components within the telescope or the spacecraft. It's strong enough to survive the launch loads that occur at the time of launch of the rockets. One of the added benefits of using the Ultim 985 is that it's thermally insulated, which reduces the risk of accidental touching by astronauts, while the components can become very hot while in direct sunlight. When talking about the CG grade of Ultim 985 in our AIS package, which was an initiative undertaken between a collaboration with America Makes, Nair, in the industry to develop a data set and that projected the repeatability and reliability of FDM and the utilization of the Ultim 985 material. With the AIS package, customers would get a T16A tip. This tip was specifically designed and tuned to optimize the performance of Ultim 985 within the Stratasys F900. It provides the end user with a very low coefficient of variance, very repeatable, and the most optimized strength with the material. It also comes with full traceability and certificate of analysis on the filament and raw materials, along with online training and documentation to maintain your systems over time to make sure that you do not see any change in performance. Through the development of the AIS offering, Stratasys was able to fine-tune the performance of the material within the system, which provided a much higher strength capability for the material, along with significantly reducing the standard deviation of the tested components. This offers a very consistent, repeatable end use part for the customers that they are able to design to and have full confidence that whatever they print will meet those requirements. The graph on the lower right, we can see a comparison of the COV of some other additive technologies comparing FDM, which is in the light blue, to MJF, SLA, SLS, other non-Stratasys FFF printers as well. As you can see from the chart on the left, this solution, combined with the Ultim 985 filament, does provide the lowest coefficient of variance and the most repeatable process. Looking at Ultim 1010 resin, also from Savic, this is a high temperature PEI thermoplastic that is capable of reaching HDTs of 216 degrees C. This material is very commonly used for composite layup tooling that is able to produce very complex shapes for customers to utilize in their composite layups. It really reduces the cost of producing these toolings through traditional manufacturing needs. But the F900 is also able to produce very large tooling, limiting the number of segments that need to be bonded together to create the tools. The Ultim 1010 material can also be used for a variety of production parts, as it does offer very high strength and very good chemical resistance. Typical industries that are utilizing Ultim 1010 today include the aerospace, space, and industrial manufacturing segments. An example use case for the Ultim 1010 is with Boom Supersonic. Boom Supersonic is a startup aerospace company that is looking to produce a supersonic commercial airliner, building the aircraft from the ground up. They utilized Ultim 1010 on a variety of different components, especially when they're testing and development phases. Ultim 1010 was a great selection for this use case as a bleed air duct because of its high temperature resistance. It's very limited thermal expansion. In doing this, they were able to save several hours in fabrication time and reduce the prototyping cost substantially, leading to a 98% cost savings and a 95% lead time savings on this one part. Another example use case for the Ultim 1010 is from UTC Aerospace. They build a number of large and critical assemblies for global leaders in commercial and military aircraft. These various ducts and assemblies can be very complex and usually are derived from several different parts in an assembly process. The challenge here was to build a structural component and reduce both the cost and time to market compared to a CNC machine part. They were able to optimize productivity and find a material with the same strength and heat resistance as the metal that they were using. Ultim 1010 provided this due to its high HCT capabilities, its good chemical resistance, and its strength to weight ratio. Again, this provided a very, very strong time savings of 95% on the part and cost savings of 63%. Switching gears from our Ultim materials to our Antero family materials, our Antero 800 NA is a PEI peak blend that is specifically formulated by Stratasys for use in FDM. It provides very high chemical resistance, very good temperature resistance, very low outgassing. It is HFST rated for flammability and use in commercial aircraft. It's predominantly used today by the aircraft, automotive, and defense industries. It is a high performance material capable of producing a variety of ductings, housings, brackets, electrical conductors, along with some manufacturing jigs and fixtures and tooling. Along with our Antero 800 NA, we also offer a Antero 840CN03. This is the same base formulation of our PEI peak Antero product with the carbon nanotubes that allow it to meet ESD compliance. So along with all the advantages of our Antero product, you're able to utilize this for a variety of electronic housings, tooling, functional prototypes, test fixtures. Provides very strong, very high temperature, chemical resistant with low outgassing, along with exceptional wear properties and an ESD compliant formulation. An example use case for the Antero 840CN03 is from Lockheed Martin Space, where they use this material to produce the outer skin of the hatch on the Orion capsule as part of their space program. They chose this material as it had been able to demonstrate consistent ESD performance, even in the harsh environments of space. They're able to certify over 100 different parts used on board of the Orion program. The second use case example for the Antero 840 is from Liberty Electronics. The challenge here was to be able to produce an ESD compatible fixture that could withstand the high temperatures and cure cycles. The solution was to utilize the Antero 840CN03 material on the Fortis 450, and in doing so, they were able to reduce their part cost by 89% and their total lead times by 86%, providing a substantial savings on this one component. Moving on to our final high performance material for today, we'll talk about the VICTREX AM 200. This is a new product just launched by Stratasys in May, so 1 month ago. With the VICTREX AM 200, this is a PEIK material. It is the first PEIK material that Stratasys has introduced. It provides excellent chemical resistance, excellent thermal performance, very good fatigue, wear, and chemical performance as well, as you would expect from a PEIK material. It is capable of meeting FST flammability requirements. It has very low outgassing. The industries we're looking at utilizing for this material include the aerospace, oil and gas, and industrial applications. The AM200 material is printed as an amorphous part. It is capable of being annealed to fully crystallize the material to gain even greater chemical and thermal resistance. And one of the key features of the AM200 is that it is compatible with both soluble and breakaway support. It is the only high performance material available with soluble support. Working with VICTREX produced a PEIK copolymer specifically formulated for use in additive manufacturing. The reason that VICTREX set out to develop this polymer is traditional or conventional PEIK materials have very fast crystallinity rates that lead to very poor interlayer adhesion, warping and curling, and delamination within the prints. So through the work, they were able to slow the crystallinity rate while still maintaining a PEIK chemistry. This offers the ability to print using the VICTREX AM200 in an FDM process and achieve very good interlayer bonding, high mechanical performance, while maintaining all the chemical resistance and thermal performance you would expect from a PEIK material. The material is printed as amorphous and can be post-print annealed to gain the full crystallinity for the material. When comparing the high performance materials within Stratasys portfolio, it is important to look at the real cost per part. utilizing these different products. As you can see from this example part, this manifold part being exhibited, produced out of either Ultim 985, the VICTREX AM200, or our Antero 800 NA. So these materials all have a different list price. There are key benefits to take away from each one of them, both in the material cost, the support costs, and then the final cost per part, keeping in mind that the final cost per part does include the time necessary for post-processing, whether that's through tanking with a soluble support or through manual removal of a breakaway support. In this case, with this geometry, we can see that the cost per part utilizing the VICTREX AM200 is lower than with utilizing either Ultim 985 or the Antero product because of that post-processing cost, in that you can tank the final part to remove the soluble support versus having someone manually remove all of the breakaway support. So with all these various high-performance materials offered by Stratasys, how, as a customer, do you decide which product is right for your application? When looking at your application and trying to determine which material best fits your needs, there's a few criteria that can help you to sort through your various options. Looking at your temperature requirements, if your temperature requirements are above, say, 150 degrees Celsius, you're really looking at Ultim 1010 or the annealed version of the VICTREX AM200, as those two materials are capable of working in those higher temperature environments. When you're looking at primarily chemical resistance while still needing a high temperature environment, the Antero products, either the 800 NA or 840 CN03, along with the VICTREX AM200, are going to give you your best results. If your applications require full traceability, including raw materials and filament for use in certified applications, you're going to look for the Antero products or the Ultim 985 CG. If your primary target is higher mechanical strength, your best options are going to be with your Antero 800 NA or Antero 840 CN03, along with the Ultim 985 CG. And if your specific geometry does require utilization of the soluble support, VICTREX AM200 is your solution, as it is our only high-performance material currently available with a soluble support.
Thank you, Nathaniel. We're now going to open up the floor to answer questions. Again, if you have any questions that you haven't submitted yet or haven't been addressed, please enter them now into that Q&A box in the bottom right corner of your screen.